Hi everyone, are you able to hear me? Alright, so great. Alright, alright. Are you able to hear me clearly? Alright, so good. Alright, so there's a question from Haritha before we start. So where should I upload the jar file? Do not upload the jar file. Instead upload the source code to GitHub. Alright, Haritha? So create a repository at GitHub, and there will be a process how to upload your source code. Okay, you'll have to check out you will have to check out the fresh repository and put the code and then commit. Great, great. So how is everybody else doing? All right. Okay, so today we are going to start with pig and pig Latin. So any other questions before we start? We have a question from Sashi. Are we using bash or C shell or corn shell? We are using bash. Okay. All right. You can generally echo shell variable and then know which shell are we using. Okay. All right. So a quick definition of pig is it's an engine for executing data flows in parallel on Hadoop. And you write these flows in a language called pig Latin. And this language Pig Latin provides you the standard operators like join, join, order by, and filter. It runs on Hadoop and it makes use of both SDFS as well as MapReduce. Okay, so basically, Pig provides you a way of executing Pig Latin. And what is Pig Latin? Pig Latin is a SQL-like language. It's a SQL-like language where it's a SQL-like language where various kinds of data flow definitions are written in the form of various standard operations such as join, order by, and filter. You will understand it as we go forward. All right. So this is how your pig program going to look like. All right. So when we are learning a new language, generally you have to go back and forth couple of times, see a little code, learn a little concept, try a little, try to run a little code. So that's how we are going to do with pig as well. So this basically is our standard word count program, and you can try to do that with our big.txt. So the lines starting with dash dash are comments. This is our first statement in pig. It says that load big.txt into input, okay, and then tokenize the here. This line is converting this input text into one word per column, okay, and then there will be one column and one word per row, meaning there will be only one column, so only one word per row would be there, and then we are grouping it, and after that we are counting it and then dumping it. All right, so that was a quick overview. So yes, it looks like a bit of SQL. You will understand as we go forward. All right. So Pig Pig is an engine which executes Pig Latin, and Pig Latin, what we just saw, is a data flow language. It allows us to describe how the data flows. The way we saw that data has been flowed from this file into input, from input it went into words, and so on. All right, you will understand the real significance of these statements as we start coding further. All right. So it allows us to describe how the data flows and how it should be read, how it should be processed, how it should be stored to multiple outputs in parallel. It allows us to create complex workflows such as multiple input files could be joined together, like in databases we join the tables together, and data is split into multiple streams. And also note that the important part is, just like in standard SQL, the way in standard SQL you don't have if statement, it is in the extensions only. Similarly, here also there are no loops and no ifs. Okay. Now, before moving forward, let me try to understand. and help you understand why do we need pigletin in the first place. So the previous sessions exercise, which was the subjective exercise, must have told you that it is little more involving to write MapReduce, right? Even for the simple task, we have to write code, and the code might grow bigger even for the repetitive task. Okay, repetitive task as joins. If you remember our last problem, it was nothing but a join and a group by. If you are coming from database background, you could see that that voting problem was straightforward a join and a group by. Okay, and those kind of problems are generally considered co-group. Okay, that we are joining on a column as well as grouping on the same column as soon as we are done with the joining. So you could see that those kind of problems are pretty straightforward in SQL or any data flow language. But in case of MapReduce, it involved it was it involved a lot of work, right? So that's probably if you think about it, you will get the answer that why do we need big Latin? And that's what we have written. So MapReduce provides operations such as group by and order by, but in a non-intuitive manner. Big Latin straightforward provides you join, filter, group by, and order by, and union and such kind of syntax, which is generally required for data joining. Big Latin, on one hand, provides you the optimizations, such as rebalancing the reducer. So, in case of MapReduce, when we are writing our own MapReduce, we generally have to decide on a number of reducers. But Big Latin does a good job at guessing the reducers. So it gives you a decent amount of optimizations. On one hand, Piglatin understands your script, just like in case of SQL, whenever if you make a mistake and you're trying to access a column which is not there in the table, it gives you immediately an error. In the similar way, Piglatin also gives you an error if your script syntax is wrong. While in case of MapReduce, it wouldn't care whether in the previous session you created map key and value contained an array. Okay, so it wouldn't know that what kind of data you have. Okay, at most you could basically define the data type of the input values, but that's not sufficient generally. So your code is mostly opaque to MapReduce. Now, in case of Pig Latin, since there is a small amount of code and and therefore it's easy to maintain. So you could see just in the previous phase that the word count problem was only 9 lines long, right? Hardly 9 lines. You can see that. Um, 1, 2, 3, 4, 5. Actually, 5 lines. Okay, the same thing would cost you around 170 lines in